working on today? How do these look different than the ones we've done for the last couple days? It equals something, right? We're not just trying to factor it, we're trying to solve it. But guess how we're going to solve it? Sometimes factoring, for sure, right? That's what we've been working on, okay? So if we wanted to do this problem and we wanted to start it by factoring, what are we going to do first? First step? Don't panic. Genevieve. What about step 2? Greatest common factor, right? Okay, is there a greatest common factor in this problem? Oh, there is, right? What is it? 2x, right? Don't they all have an extra x we can get rid of? So if I factor out a 2x, what's left? X squared minus 6x. Don't call yourself stupid. That's unkind. Plus 9, right? Now that looks familiar, doesn't it? How do we solve that? How do we factor that? Can we do the shortcut on it? Oh yeah, okay, nice. AC is 9, B is negative 6, so it multiplies to be 9 and adds to be negative 6. Negative 3 and negative 3. I'm just going to put factor. We know how to factor now, right? Okay. Now here's the question. If this times this times this equals 0, what has to be true about at least one of these? If I multiply any two numbers together, or in this case 3 numbers together, and I get 0, what's the only way that can happen? If one of them's 0, right? One of them has to be 0 for me to multiply stuff together and get 0, right? Which one? Yeah, I don't know either. Okay, so, but to figure out all the possible solutions, we just have to think all of them are 0. Okay, so I'm going to think this one's 0, I'm going to think this one's 0, and I'm going to think this one's 0, right? So if I'm solving this first one, how do I solve for x? Divide by 2, right? What does x equal? What's 0 divided by 2? 0. How do I solve this one? Add 3. If I add 3 to both sides, I get x equals 3. If I add 3 to both sides, I get x equals 3. Now, I need you to know the fundamental theorem of algebra. That's what it's called. It's called the fundamental theorem of algebra. Okay? Fundamental theorem of algebra. I'm going to translate it to English for you, if that's okay. I'm not going to tell you what it is word for word, if that's all right. Fundamental theorem of algebra says that my degree, which is my highest exponent, that's how many solutions I should get. Oh, look, 1, 2, 3. We got 3. Done. Okay? Now, some people get confused because these are the same. What do you say to that? Okay. Yeah, I still got 3 answers because I still set each factor equal to 0 and got 3 answers. Okay? Now, I do want to show you something that I think is interesting. But then again, I'm a math teacher. But I think you might think it's at least a little interesting. Okay? I'm going to put this, I know you can't see it yet. Hold on just a second. I'm just entering the equation. Whoa, 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 whoa. Let me zoom in so you can see it. Really? Is that how you're going to be today? Rude. Calculator. Minus 12x plus, oops, squared. No, not that squared. Stop being a jerk, calculator. 18x. What did I do? I said 18x and you didn't type it in. if I lean it sideways, you can see it. Okay. Oh, now you're going to... Oh. I don't know why it's being a jerk today. Sorry. Maybe if I scoot it. Oh. Oh, that's better. Okay, awesome. What solutions did we get? 0, 3, and 3. Looking at the graph, what's happening at 0? It's going right through the 0, right? What's happening at 3? Oh, it's bouncing. That's not the technical term. That's the term that makes sense in my head. Do you see why I call it bouncing? So at 0, when I only had one answer, it goes through the axis right there. But at 3, where I had 2 3s, it bounces there. We're not quite there yet, but I'm going to give you a little bit of foreshadowing here. This has a multiplicity. That means I have more than, like I have the same answer that happens more than one time when a bounce happens. Okay? If it crosses through, just like this says right here, that's happening once. But where there's a bounce, there is a multiplicity. But I just figured that out by when I solved for the answers. I got 1 0 and I got 2 3s. So this one crossed through, this one bounced. Okay? Questions? How do you feel about factoring? You love it, don't you? Awesome. Okay, so let's do this problem. Now, when I do this problem for you, I'm going to model what I want you to do for your homework. Is that fair? Both of the next two problems, in fact. Okay? I'm going to show you exactly what I want to see on your work for your homework. Obviously, whatever the computer asks for, that's what you're going to put in as your answer, right? But as far as your work goes, this is what I want to see. Okay? There's 4 terms here. What would you try first? Grouping, right? There's 4 terms. We would group. Well, what's common in these 2 terms? X squared. If I factor out an x squared, what's left? X minus 8. What's common in these 2? Nothing. I could take out a 1, right? But is this going to give me x minus 8? So can I factor by grouping? I can't. So I have to have another way that works. Okay? So here's what we're going to do. We're going to call my leading coefficient, that very first term, we're going to actually call it Q. And my constant, we're going to call that P. Because what the rational root theorem says is if I take all the factors of P and divide it by all the factors of Q, that will help me narrow down the possible factors for this polynomial. Okay? Now, does that make sense? No, it doesn't. We haven't done any examples, right? Factors of P, factors of Q, that's just nonsense right now. Well, tell me what the factors of 20 are. 1, 2, 4, 5, 10, and 20. Now, why in the world did I put plus or minus in front of that? Right? Because 1 times 20 is 20. But negative 1 times negative 20 is also 20. Right? Well, what if that was a negative 20? Would I need the plus or minus then? I could have 1 times negative 20, and I could have negative 1 times 20. So I still need the plus or minus, don't I? Okay? Now, what are all the factors of 1? Oh, 1. Okay. Plus or minus 1. I still need the plus or minus there too, don't I? Okay? Because I could actually have 1 and negative 20, which would be negative 20. But if I divided it by negative 1, wouldn't that still be positive 20? I know. That's just why we put the plus or minus, because we want to cover all of our bases, right? Okay? Now, what happens if I divide everything in the numerator by 1? What do I get? Don't I just get everything in the numerator? Because anything divided by itself is, anything divided by 1 is just itself, right? So here's the deal. What we're going to do is we're going to find all the zeros or factors or solutions or X-intercepts. There's like 8 different things that these are called. Maybe not 8, maybe 5. Okay? There's a whole bunch of names that what we're trying to solve for today are called. And I'll try my best to make sure you understand the difference. Okay? But what I could do is synthetic division, because you guys are pretty good at that, right? I could do synthetic division with literally every possible number for infinity to find my solutions. Or I could try these 12. You'd rather do these 12? Wait, 1, 2, 3, 4, 5, 6. Yeah, 12, because there's positive and negative, right? Okay, so you would rather try the 12? So let's start with synthetic division with 1. Is everybody okay if we start with 1? Okay, 1. I'm going to do synthetic division. 1, negative 8, 11, 20. Tell me why. What do you mean? No, you were right. They're saying they would rather choose an infinite number of numbers. Okay, so that means we have to start at 1, and then negative 1, and 2, and negative 2, and 3, and negative 3, and 4, and negative 4, and 5, and negative 5, and 6, and negative 6, and 7, and negative 7, and 8, and 8, negative 8, and 9, and negative 9, 10, and negative 10, and 11, and negative 11, 12, and I don't want to do that anymore. I would just rather try these 12. That was the right answer. Those people are not your friends. They're trying to make you say the wrong thing. So how do I do synthetic division with 1? First of all, why did I start with 1? Because it's first on the list, right? I could have started with any of these. I could just randomly have chosen any of these 12. I'm kind of a linear type of person, so I started with the first one. Okay? Okay, 1. What am I looking for? What am I doing synthetic division for? The remainder theorem says if I get a 0 here, this is a 0, which I can make into a factor. So what I want is a 0 in my remainder. Okay? So 1, 1, negative 7, 3, 4, 4, 24. Nope, didn't work. Sad face. So negative 1. 1, negative 8, 11, 20. Okay, 1, negative 1, negative 9, 9, 20. Ooh. So what does that mean? That means this is a 0. How many more do I need to find? Well, how many answers am I looking for? 3. And if I've already found 1, how many do I lack? 2. Okay? Now, if we're doing this the most difficult way possible, I'm going to keep doing synthetic division for all of these until I find 3. So if you choose that way, you go right ahead. Can I show you a slightly easier way? And by slightly, I mean a lot. What's left right here? Remember, that's my remainder, so that's my constant, so that's my x term, and that's my... So this says x squared minus 9x plus 20. Does that look familiar based on the last couple days? Could I factor that? To what? I can do the shortcut, right? Because my leading coefficient's 1. So AC is 20, B is 9. What multiplies to be 20 and adds to be negative 9? So both negative, right? Negative 4 and negative 5. So these are factors. And you're just going to have to be careful and look at the directions. Because do I want factors or do I want zeros? If I want factors, there's 2 of them. If I want zeros, here's 1 of them. So here's what we're going to do. We're going to list all the zeros. I know I have a -1 as a 0. What are my other 2 zeros? Well, remember, to get a 0, I've got to take my factor and do what with it? I have to set it equal to 0. That's why they're called zeros. Or at least that's what I tell myself in my head. So my 3 zeros are -1, what? 4 and 5. What if it asks for factors? What are my factors? Yeah, for sure, I have these 2 right here. So x minus 4 and x minus 5. But what factor goes with that 0? How about x plus 1? Does that make sense? If I set these equal to 0 to solve to get the 0, wouldn't I have to kind of go backwards to get the factor? I'd have to add 1 to both sides, which would give me x plus 1, x minus 4, and x minus 5. Okay? These, besides being called zeros, could also be called solutions. So was that difficult? So writing all the possible all the possible zeros is here. We started with synthetic division until we found 1, and then we took it and factored it. Was that difficult? But that's not even the easiest way. If I put in x raised to the 3rd minus 8x squared plus 11x plus 20, what do you notice? Where's the graph crossing the x-axis? -1, 4, and 5. Okay? Any questions? So what's going to be required on your homework then? What I want you to list is all the possible zeros. So do this step, all the possible zeros. And then I need to see at least 1 synthetic division, because we still need to practice that. Okay? Which means, can you look at the graph to find 1 possible x-intercept and use that as your number out here? Or do you just want to guess? Oh, use the graph? Okay. Use the graph and find 1. Now, can you find all of them on the graph? Sometimes. Most of the time. Right? But for sure, use it to find 1. Do your synthetic division. So like here, figure out what's left, factor what's left. That should match what's on the graph, right? Okay. Let's do one more example. Because I did say sometimes, right? I did say sometimes. So let's do one more example to make sure you understand what I mean. Possible factors. Or I guess zeros is better. Sorry about that. Possible zeros. How do I get those? The factors of the last number divided by what? The factors of the first number. So what are all the factors of 40? 1, 2, 3 doesn't work, 4 works, 5 works, 6 doesn't, 7 doesn't, 8, and then we're back to the partners, right? 5 and 8, so 4 and 10, 2 and 20, 1, what is that? 1 and 40. Divided by all the factors of the first number. So this is different this time, isn't it? A little. Because we've got a 1 and a 3. So I have everything in the numerator divided by 1. Then I also have everything in the numerator divided by 3. So what's 1 divided by 3? What's 2 divided by 3? What's 4 divided by 3? 5 divided by 3? 8 divided by 3? 10 divided by 3? 20 divided by 3? And 40 divided by 3, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 32 possibilities. Guys, 32 possibilities is still better than infinity possibilities, right? And remember what I told you to do now? So let's look at our graph to see if I can figure out one of my points that I know for sure it crosses, right? So I want to graph. So I want to put in 3x raised to the third minus 25x squared plus 58x minus 40. Oh, what can you see? How many solutions am I supposed to have? 3. Can you see it cross the graph of the axis 3 times? Yes. Can you tell exactly where all 3 of those are? No. Okay. But you know for sure 2 and 5, right? You know for sure 2 and 5, right? So here we go. Do you want to use 2 or do you want to use 5? 2. Okay. So if we use 2 for our synthetic division, 3, negative 25, negative 58, and negative 40. Now we know for a fact what should be in this box. A 0, right? Okay. So I just need to make sure I'm aiming for that. So bring the 3 down, multiply 6, add negative 19. Multiply negative 38. Can I fix this real quick? I accidentally wrote negative 58 when it's positive 58. You guys know my negative signs are my nemesis. Sorry about that. So 20, and then 40, and then 0, right? All right, what can I do with this? So I have 2 choices right now, right? Okay, I could go ahead and write it as an equation, or I know my other one, don't I? Don't I know 5 works also? So I have 2 choices. I can go ahead and write this out as 3x squared minus 19x plus 20 and do my AC and my B. Let's go ahead and do that so we practice that. AC is 60, B is negative 19. Can you think of 2 numbers that multiply to be 60 and add to be negative 19? Do you think this is always the best course of action? No, but we could do it, right? We know how to do it. We've been doing it the last couple of days. It's maybe not the easiest choice right now. So what? Negative 15 and negative 4. Perfect. So 3x squared minus 15x minus 4x plus 20. Right? What's common in the first 2? 3x, so x minus 5. What's common in the last 2? Negative 4, so x minus 5. So what's common? X minus 5, and what's left? Okay, so my zeros would be x minus 5 equals 0 and 3x minus 4 equals 0. Ooh, look, x equals 5. Isn't that what I got? Okay. Isn't it what? Okay. If I add 4 to both sides, 3x equals 4. Oh, that's why I couldn't see it. It was a fraction, right? That's why I couldn't tell exactly where it crossed the axis. But look at this. It's on my list. If I would have done synthetic division with all 32 of these numbers, I would have found it, right? Okay. Now, can I show you another option? What if I started right here with 5? Because didn't I know that it worked? 3, 15, negative 4, negative 20. What does this translate back into? Remainder, constant, x term. 3x minus 4. Oh, look. I got that over there, too. If it asks for zeros or solutions, what is my answer? 2, 5, and 4 over 3. What if it asks for factors? X minus 2, x minus 5, and what? 3x minus 4. Absolutely. Which one of these is more correct? They both are, right? They both are correct. I don't care which way you do it. If you want to factor like we've been doing, if you want to continue with synthetic division, we still got the same answer, didn't we? Any questions?